Okay, so moving on to part 3, there's going to be 3 separate videos of this just to break it up a little bit. So now we're going to get specifically into families of the periodic table and some specific element examples. So if you have your periodic table with you, feel free to color code it. It's not going to be color coded exactly like, well, actually it's going to be pretty close to this color coding. But anyway, if you want to color code, feel free to. It's going to help you eventually. But if not, you can always just refer back to your notes and video. Okay, so our first family on the periodic table is called the alkali metals, and I've highlighted them in red here. So this is group 1 of the periodic table, excluding hydrogen. So notice that hydrogen is not included. So we have lithium, sodium, potassium, rubidium, cesium, and francium make up the alkali metal group. So it says it in the name. The alkali metals are all metals. They're metallic in color in their pure form. These metals are very soft, which is hard to imagine because we think of metals as being hard. I have a video that I'll show you that in. They're so soft that you can cut these with a butter knife. So a picture here showing you how soft they are, but I'll show you a video as well. The alkali metals are the most reactive metals. They react so violently with just air and water that you have to keep them in oil to keep them from reacting. You can't just keep them in a jar full of air. And if they touch water, they react. And I'll show you a video of that as well. So just some examples: lithium, sodium, potassium, as you can see, stored in a jar with clear oil. And just like all metals, these are very good conductors of heat and electricity. So group 1 is the alkali metals. So here's a quick video. I'm not going to show you the whole thing, but so you can just get an idea about these metals.
Group 1 of the periodic table is a group of reactive metals. Lithium, sodium, and potassium are at the top. These metals are so reactive, they have to be stored under oil and need to be handled with care. Lithium is so soft, it can be cut with a knife.
That's metal. Notice the
You can see how shiny the freshly cut surface is. But leave it exposed to the air for a few seconds and it quickly begins to tarnish. It's reacting with the air. This is sodium. It's even easier to cut, and again the shiny surface soon discolors. Potassium is even softer and reacts so quickly it touches immediately. Another way of comparing reactivity is to place the metals in water.
Reacting with water. So they drop it
Lithium
in water
floats.
and it starts fuzzing and bubbling and smoking, if you will. A gas is being produced.
It reacts immediately, fizzing and skating around on the water, which is evidence that a gas is being produced.
Fast forward just a little bit.
Putting a tiny amount into a boiling tube. A squeaky pop means it's hydrogen. The indicator shows the solution is alkaline. So how does sodium react?
Okay.
Again, it floats on the water and fizzes.
Fizzing around immediately. It's moving because the gas that's coming off of it is pushing it around.
Hydrogen. And the solution is alkaline. Water, sodium hydroxide and hydrogen are formed. Sodium is more reactive than lithium. It's below lithium in the periodic table. Potassium is below sodium. So how do you expect potassium to behave?
So notice it immediately reacts and actually ignites when it hits the water. So a very violent reaction with water, and then it combusts.
Potassium is definitely more reactive than sodium and lithium.
Those are our alkali metals, very reactive. So some examples. Sodium is found in light bulbs, street lights. It gives that orangey glow. Sodium is a component of salts, including table salt and baking soda. So just because it's a chemical, remember, it doesn't have to be harmful. Lithium is found in batteries. So they ask you at the post office, are you mailing in your lithium batteries? These are very powerful, long-lasting batteries. Lithium is also found in some medications like antidepressants. And potassium has many uses. It is found in fertilizer. It's a key component for plant growth. It's found in gunpowder, but you also have potassium in bananas, and your body needs a certain amount of potassium to be healthy. So as I said, just some examples, you don't have to have something be harmful, but in certain cases it can be. You're not going to eat fertilizer, but you can eat a banana. Okay, group 2, which I have again highlighted. This is going to be the entire group 2, so beryllium, magnesium, calcium, strontium, barium, and radium. These are the alkaline earth metals. So once again, they're metallic metals. They are harder than group 1, so you can still cut them, but not as easily. They're also less reactive than group 1 and still good conductors. So just another video, kind of like you to see them in action.
The alkaline earth metals are generally softer than most other metals, and they react readily with water, particularly when heated. Each has 2 valence electrons in its outermost electron shell. They are powerful reducing agents that readily give up electrons to other substances. The element beryllium can absorb large amounts of heat, which makes it useful for spacecraft and aircraft construction. Magnesium is a light metal. It is combined with other metals to make racing bicycles, airplanes, missiles, and other products that need to be lightweight and strong. Calcium is an essential element for countless living organisms. It forms the foundation for everything from shells to teeth and bones. Strontium goes into colorful flares and fireworks, and phosphorescent paints. A radioactive version of this element is one of the most deadly byproducts of nuclear fallout. Barium is a heavy silver metal that is used in spark plugs, vacuum tubes, and fluorescent lamps. And radium is an intensely radioactive element that doctors once often used to destroy cancer cells. In their pure forms, the alkaline earth metals are shiny silvery gray metals. They have relatively high melting and boiling points, and they are good conductors of heat and electricity.
Can almost give you a welder's
These
shock.
metals have a gray-white luster when they are freshly cut, but they tarnish quickly when exposed to air.
Butter knife.
The heavier members of the group tarnish especially quickly.
With water.
Beryllium, the lightest of the alkaline earth metals, is hard enough to scratch glass. But barium, the heaviest, is only slightly harder. Alkaline earth metals react readily with water,
once again,
especially when they are heated.
They're very,
they combine easily with other elements, and as a result, are never found in their pure, uncombined forms in nature.
Like I said, magnesium gives that very bright white.
Although they are harder, stronger, and denser than the alkaline metals,
so still reactive, but definitely not as violent as reactors as the alkali metals. So group 2 is alkaline earth metals. So just some examples for you. Beryllium is used in aircrafts and space shuttles and satellites. It's not a very heavy metal, but it still is strong. Magnesium, as I said, is found in sparklers. It burns that very bright white that almost hurts your eyes. Calcium, you should know about calcium. It's in milk, your bones need it. It's found in concrete, very strong. Seashells are made out of calcium. Strontium is found in red fireworks. It gives the red color when it burns. And barium is found in green fireworks. It gives the green color. So that is the alkaline earth metals group 2. Last part of this video, the transition elements, or you can call them the transition metals. This is going to be the very fat rectangular portion of the center of the periodic table. So this is going to be group 3 through group 12. So all those groups. So these are still metals. Some are more shiny than others. They are all solid except for mercury. So this is where mercury ruins that all metals are solid statement. These are harder than group 1 and group 2 metals, so you're not going to be able to break these apart easily. And they're still good conductors, but very much less reactive. So think about gold and silver. We wear those with jewelry. They're non-reactive. If you have sensitive skin, they suggest you get gold or pure silver jewelry because it's not going to react with your skin. So I don't have a video on those ones, but you should probably be a little bit more familiar with copper and zinc and gold, things like that. But just some fun ones. Yttrium is a very expensive metal. It's found in computer screens and TV monitors. Very expensive. Titanium is a very light metal, but very strong. So they use titanium in bone pins. So if you have any type of bone pins, they're probably titanium. They don't want to put something in your body that's going to weigh you down, but they do want something that's going to be strong, withstand life. Golf clubs, baseball bats can also be made out of titanium. Very strong. They're going to hit the ball far, but they're light enough to swing. Zirconium is found in fake jewelry. So they call it cubic zirconium. So it looks like a diamond, but it's not. It's much cheaper. Still pretty. And they can add colored dyes to this gem to make it mimic gemstones. Tungsten is a very strong metal. It's found in light bulb filaments, and sometimes it's found in jewelry, usually men's jewelry. It's a little heavier and a little more withstanding of maybe labor jobs that men are more entitled to, I guess. And then mercury, we don't use it anymore because it is harmful, but it was used in thermometers and dental fillings because they could just pour it into the dental cavity and heat it to solidify it, and it was done. But it's harmful, so we don't use it anymore. So those are some of the transition elements or transition metals, groups 3 through 12. So we've covered most of the metals on the periodic table at this point.